Hi, this is Mr. Shumway. This video clip explains how to use what we've learned about heat capacity to see if putting a power plant on the San Juan River would be a problem with heating up the river water too much. So let's say it's an 850 megawatt power plant operating with an efficiency of 25%. The nearby river is used to carry away excess heat. So how much heat is transferred to the river each second? So first of all, we need to figure out how much energy is wasted. So let's figure out the total energy and subtract the electrical energy from that. So we know that 25% of some total is equal to 850 megawatts. So let's find out the total energy put into that thing. So the total is equal to 3,400 megawatts. Okay, so if we subtract the 850 that was useful electrical energy, equals 2,550 megawatts. A megawatt is, well, a watt is a joule per second, and mega means 10 to the 6th. So it's 2, whoops, with 6 more zeros, because mega means 10 to the 6th. So it's 2.5 billion joules of heat. Uh-oh, are we going to warm up our river? Well, let's say our river has a flow rate of 5 million joules every second, of 5 million kilograms of water every second, 5 times 10 to the 6 kilograms every second, past a certain line across the river. So let's find out how many joules for every kilogram. And then we'll be able to figure out how much the temperature of the river rises. So we have 2.55 times 10 to the 9th joules per second. And we have 5 times 10 to the 6th kilograms per second. The per second cancel, so we have joules per kilogram. When we're dividing exponents, 10 to the 9th divided by 10 to the 6th, we can just subtract exponents, and we know that they'll be in units of 10 to the 3rd. 2.5 divided by 5 equals about half. So we have about 0.5 times 10 to the 3rd joules per kilogram, which is 510 joules per kilogram of water. Well, it takes 4,000 joules to heat 1 kilogram of water 1 degree, so we know it's going to be less than 1 degree. And then per degree for the heat capacity, joules per kilogram, so we just have units of 1 over degrees, which is just degrees. So I used 4,200 joules per kilogram, but anyways, that all comes out to be about somewhere around 1/10 of a degree. So that's not going to heat up that river a whole lot, especially if you consider that the river water changes, oh, I don't know, 20 or 30 degrees from winter to summer. So 1/10 of a degree, I don't think the fish are going to notice that at all. I don't think it's going to change the wildlife anyways. At least that won't be what would hold back production of or the manufacturing of nuclear power by San Juan River.